Hello everyone and welcome to this my session for AI Expo Africa 2020. I'm so glad to be a part of this. It's a pity I'm not there with you, but the pandemic should be over soon and perhaps next year we can meet in person. So my session is called Simplifying AI for the Enterprise, and I have a lot to cover in just 30 minutes. So I'm going to start and run through it, and I do hope that you enjoy the session. Okay, so let's have a look. Simplifying machine learning for the enterprise. Where do we begin? What is the current state of machine learning today? So from what I can see, it's actually going along very nicely. A lot of companies know exactly what they want to do. We have some nice use cases now. The ML teams, data scientists are growing. It's becoming a normal function within these companies. And in fact, the constant feedback I'm getting is around skills. And that is actually a big part of what I will cover today, the skills problem. Before we go there though, in terms of ML AI, we always said that it will become transparent. It will become a part of your business applications. So you've got things like bots and agents. You have cognitive services, mining safety. That's something I've seen being done in South Africa. AI assisted professionals. So just using AI to do your job better. Knowledge mining is growing now, and autonomous systems as well. So this is just a small subset of where we are today and what's possible. Now, I mentioned the skills shortage, and this is something we need to consider because even after, I think, 3 or 4 years of really good growth, getting machine learning projects out there into the large corporates at least, even some of the medium-sized and smaller corporates as well, the skills issue is still a massive problem. Good news for now, if you want to get into this field of expertise. I just took a few articles from searching earlier today, and as you can see, still a problem. What it also means though, and this is the key point, we will have varying degrees of skills delivering on machine learning and AI, which is a critical function already in a business, and it's directly impacting your competitiveness as a business. So keep that in mind. And what these people need to do, that's pretty, it's a wide range of things. It's not as simple as building an application. So let's try to break this down. On the left, you have data preparation, and some of you will know we call that data engineering. Now, data engineering is a topic in itself. I'm assuming that the data curation is going to be taken care of. A lot of companies that I work with are trying to standardize on a model where a central body does data curation, data quality, takes care of all the data engineering, and then makes it available to various business units and people across the business for their machine learning needs. This is one thing we need to do to simplify machine learning. So if you haven't got that at your organization going, something to look at. It's not always possible though, because you have silos of data still. You have different business units where some of the data from systems business unit A is using has little in common with the common data set at the central organization. So that's something to consider. What we need to do as vendors though is allow that data exchange, data management, a central location for data, and the building of data lakes is where this comes into effect, and that's becoming increasingly popular. Of course, as you would have guessed by now, a lot of what I'm going to show you is how cloud is making all of this a little bit easier and solving some of these problems, right? Then we come to the meat of what I'm going to talk, building and testing and training. And here, I'll really break it down in the next few slides. There's various ways of doing this. We have various level of skill here. When we get to then training and testing, we really hit the infrastructure. So at the beginning, we need to consider a really nice infrastructure on the left there for data engineering and how we host that data. We need to look at IDEs, a wide variety of IDEs for different people, depending on their level of skill, to build models. And then testing and training, where will that run? How much horsepower do we need? And then we come to the right side of the screen there, deployment, And really, that's I'll cover that towards the end of the talk, right? So that's the what, that's the process. Now let's go through a scenario. So it says there, more personas are building machine learning models. Okay. Now, I think even Microsoft cannot accommodate all the various personas out there, but I'll identify a few. So very simple double axis, right? A different level of skill in terms of coding, from a person that wants to write no code at all to a person very experienced in coding. And then on your y-axis there, no ML experience at all the way to an ML expert, probably a PhD, that type of person. And why do we start at no ML experience? Because there are business people getting into this. They have to deliver today on this. It's part of their KPIs. It's part of the business function. We need to accommodate them. We need to popularize machine learning, but not at the cost of accuracy. We don't want the business to start seeing incorrect results and then losing faith in machine learning. This is actually the challenge, right? So we, as vendors and technology people building these tools for you, what we had to consider was basically, okay, can we unify what I showed you on the previous slide? Can we make all of this easy? This entire process, and it's quite a lot. And I wouldn't say we're 100% there yet, but we are getting there. And then how do we accommodate all of these people? Sourcing data, hopefully from a common data source, curated data, right? So that's another thing that you want. And then right in the IDE of your choice, depending on what you see on this screen here. And just for example's sake, we've got a few people, get a few personas, right? And allowing them to build and deploy and get to the results, so that the wheels of business need to turn. And that's the aim of the entire exercise, right? So Samantha, for example, is an ML expert. She understands algorithms and machine learning quite well, regression, classification. She really doesn't want to write code. So what do we give her? And what do we give the coder, like John, who's been coding for 20 years, but is just getting into machine learning today? So those are things we'll have to look at. What we're also finding, by the way, coming out of some research, is that this might surprise you, but typically you'll have about 15 in a large organization. This is what was found. You'll have some people at the top, roughly in equal balance. But really, you will have more people like Dean in the bottom left quadrant. And if we don't accommodate those people, then we have a problem. So let's take a look, right? So that other slide that I showed you, I'm breaking it down into the physical pieces now. What we need to figure out is how we have a shared compute target for the training and testing and preparation of the models. Certainly, all of those people, except maybe the hardcore programmer, but even him or her, doesn't want to really be managing virtual machines. And I'll tell you the one thing about machine learning, some of you will agree with me. It's not an exact science like running an application, or it's even less of an exact science. You really sometimes don't know how much horsepower you need, not just to train, but to even score a model. Obviously, sometimes training, you find that it's a little bit imbalanced. So the compute target, the set of computational nodes that you can scale up easily, how are we making this available to the 4 types of personas that I showed you on the previous screen? So that's something to consider, right? Easy access to compute, number 1. Number 2, shared data stores. We want curated, trusted, verified data coming in. And where does it sit? So that all 4 of those personas can actually access these easily, right? Different ways of doing experiments, and I'll talk about that, and then deployment is something else to consider. So if I look at a use case that we've got here, if I did a simple price prediction, now let's say price prediction would be a type of regression, how would the different personas approach this type of problem? Okay, now remember, you might say, well, if I'm doing a price prediction regression for pricing of a product at my company, I'm going to give it to Daniel or Danielle, sorry, looking at the picture, and or maybe John, but probably somebody higher up on the y-axis there. But you know, you don't always have that luxury based on what I've shown you on the previous slide. And you will have situations where a dean wants to build a custom model, because a custom model is always better with your data, right? You don't want to run a model, somebody like Dean, that's been trained on somebody else's data. You want it trained on your data. That's where it's giving you the most amount of value, okay? So very quickly now, what we've done, and this is obviously in Azure, but you know, I think the entire industry is moving to this. We've got 3 key options with Azure machine learning as one example, but they built on the same underlying platform, and that's actually what I'm going to show you, which is very interesting, right? So somebody like Danielle could do notebooks in R or Python, and they shared compute and shared storage. You're sourcing the data from a reservoir, it's been curated. Somebody else like Dean, for example, or I can't remember the name, but visual interface, the same data, the same curated data, the same compute, so that IT can manage costs and scale and things like that in the cloud. But I'm going to use a visual interface. And then the controversial one, which is AutoML, which I'll spend the bulk of my time actually showing you, right? And let's see where we've got to and how that actually simplifies the process, okay? Okay, let's take a look very quickly at what we have to help us solve or simplify some of those issues, right? Now, this is a single pane of glass. This is an Azure machine learning instance that I've created. And on this management pane, I get an overview. I can look at logs. I can see my compute here, different sets of compute clusters that one can set up. And at the bottom, I can look at some metrics and alerts that I've set up. So I've just set up a single compute instance, and that's the virtual machine size there. I think it's 4 CPUs. Then when I go into the management interface, where I want to start creating, there's a few more options, right? So there's compute again, you'll see similar things, data stores. So I've actually got a single blob storage where curated data can come, and anyone using it in any manner accesses the same data. You also have things like write back. I can create pipelines here into that data store, right? So here's one that was created earlier on. I have certain data sets that I could then reuse, and that reusability is very, very important for what we want to do in terms of that simplification process, right? The compute, by the way, once it's set up, you don't really have to manage things like Kubernetes. You can if you want to. You'll see that it's running. Jupyter Notebooks accessed it the last time. Now when I come here to home, I would like to run an experiment, for example, and I can choose one of these 3 options. So firstly, if I'm somebody that doesn't want to get my hands dirty writing maybe Python code, this is the visual interface. So here I've got the just a simple data set with automobile data, and given the condition of the car, the make, the mileage and everything, I would like to predict the value of that vehicle. And so this is what I start off with, and I run through a process visually. I can drag and drop these blocks. So the creation process, and you're doing a bit of data cleanup and feature engineering here as well. Select linear regression. I can run the model off the shelf, and I've just run this just to save time, and you can see the scored result when it loads. The column right at the end there, it's basically the actual, because we're testing against the training results, 9.6, and it predicted just over 10. 6.3 predicted 5.9. So when we go to evaluate the model that was automatically created using this process, we'll see coefficient of COD determination about 0.86. So you want to get that a little bit better, but it's a good starting point, and you can tweak the linear regression block from here. Now, some people might want to do that. Other people may say, well, actually, you know what? I just want to work on Python. So you set up the common data store. You set up the common managed compute. That's great. All the infrastructure is there. There's logging. There's pipelines for refresh data to come in. But I want to use that, but I want to use that data in my comfortable notebook environment and maybe do R or Python. So you click on the, notebooks, and here I've just done a simple linear regression on another set of data. I can run it in this view or the proper Jupyter Notebooks view. Just click there. You can see you select the compute cluster. So it's actually only 2 cores. So it's not a lot. And then here you'll see this reads it from the blob storage. We just want to do a regression model to see which of the first 4 columns affects the score on the last column. There's the text file that I'm bringing in, pandas, data frames. Some of you would be very familiar with this. And then here, I can run this again. It's fairly quick. And that's the initial regression line that I get. And then from there, you can go so far and so far. So that's an element of simplification for both of these views. But the real thing is the common data store, the common compute. I can come here and really, add a new cluster and maybe put it there. It won't be used, and really choose something a little bit more beefy. And then when I'm here in my notebook environment, I can then say, okay, well, actually, I need this to execute quicker. Now run it on the second one, which is, let's say, 16 cores, and the results come in a lot quicker. So that's very, very useful.
Now, AutoML is a controversial topic, especially amongst data scientists, but there is a lot of value if we can get it right. So let's look at the state of AutoML, certainly with respect to Azure.
Right, so the question is, have we simplified ML with AutoML while maintaining accuracy and other standards as well? So let's have a look. So from this view here, the studio, I'll click on AutoML. And let me tell you what I'm doing. You'll see a run there already. This is the data set that I'll use, and this is basically, I want to run a marketing campaign, for example. We've done regression, so I'll do classification now. So I have all kinds of demographics here on individuals, but obviously not PII. And I've got the one column, yes or no. The column name is just Y. Do I want to run a campaign? So this individual here, for example, would qualify. I'm going to feed that in. So what do? How complex is it to actually do this? Well, you come here and you say new automated ML run, and you can select the data set. Now all that is, if I hadn't had that, I would have to say create dataset from a local file. Obviously in the curated environment, it would come from the blob storage or the data lake, marketing campaign 3. This is just to show you, and you would browse and upload the file, which is that one there. And but I've done that already, and that is this one here, marketing model, and I'm storing it as a tabular format file, and it will just give me a little preview. So there are the columns, including the one that I want to classify on. Bring up some statistics as well, but we don't really need to see it at this point. So I'm happy with that. I've selected the data set, step 1. Step 2, what would I like to call this? So I could call this marketing targets, because I've run it before. Marketing targets 3, because it's a new instance. And the most important thing is, what is the target column? So that Y, yes or no, that is the target column. So that takes care of the data. Now, which compute cluster would you like to run? Here's the compute cluster that I did show you earlier. And then there's just one more thing. There's just 3 types of tasks: regression, time series, but this obviously is classification. I just want to run classification on that. There are some advanced settings, but I'm not even going to change any of those. No, don't want to save that. And there's some featureization settings as well for the data, but I'll cancel that as well. All I'm going to do, having done that, just to show you the simplification, I'm going to hit finish, and it's going to create a new automated ML run on that data, on that column. Now, how we've enabled accuracy while simplifying this. So the task itself is very simple. It's going to start running in a second. It actually goes and runs a whole bunch of algorithms against that data set. Obviously, in this case, classification algorithms. So if I go to models, you should see, let's go to details, and you should see a list of these. So if I come here, let me just go there, right? It's going to take a while to run, and this now is the new run that it's going to do, but it'll take a few minutes. But in the interest of time, let's just look at the run I did earlier about an hour ago on the same date. So I ran this today, and if I click here, this is the interesting part. Okay, so here you will see that it basically did a whole bunch of runs. I'm not sure exactly how many, but many algorithms. And what's nice is that I can filter by the accuracy. So the worst was just a 0.68, not good at all. But the best one was this voting ensemble, a 0.91 accuracy. It took 58 seconds to run. It's completed. And then I can go and view the explanations. So the explainability is quite important as well. And here you get some nice charts and stuff like this. So the citizen data scientist can actually run this, but then the proper data scientist, I'm not sure if that's offensive or not, but the real data scientist, or the more experienced, I think that's a better term to use, can come and have a look. And you see here the importance of certain features. Duration and employment rate was more important. There are some other charts as well, which you will see on the main screen. Just click here, a whole bunch of stats there that you can have a look. So that actually ran, and that was the best. So since that was the best model, if I'm happy with it, I now need to deploy it. That is literally at the click of a button, right? You click here, you give it a name. There's a few more steps if you choose Kubernetes. If you choose container instances, you simply name it, and I'm not even going to enable authentication and go deploy. And I've done that already. So when you do that, you get to endpoints, and here's the model I deployed earlier. Very quickly, very simple and straightforward. If you're using authentication, which you should do, there's a few more steps, and I get this REST endpoint. Okay, and it will run in my Azure resource group. Now the more interesting thing is the consumption of this. So if I come to Power BI as one example of consuming it, right? What I've got here is I've created a quick report using the original source data. So it's not the best data. It's the same data. I've just put it in, and I've said, okay, the yes/no column, here's the campaigns by jobs and education, blah, blah, blah. However, if I wanted to then run and score, let's say this was a different set of data, not the training data, how would I do that? Can I score my new data in my report and then visualize it and present it as a report? All of that would be great if we could do that, but how do we simplify that process? So the tip is click on transform data. If you've been wondering how to do this in Power BI, you actually need to go into the Power Query editor. And when you're in Power Query, what you will see is this block that we put in, and AI Insights. You will see a button, Azure Machine Learning. That's the one you click on. And in my case, I don't even have to put the REST endpoint there, because I'm logged in with the same account for my Azure subscription, and I deployed and created that model. It'll actually pick up all the models that I've deployed. It's just the one, and you can double click on it. It'll show you the columns. You click OK, and then what it will do, it will then apply that to the data set, and it'll actually score it. Now what helps me here, by the way, on that last screen, the column names are the same because it's the same data, right? You can see it's the second time I've applied it, but otherwise you might have to do a bit of a mapping. But you can see it's quite interesting. All of these are the same. No, they're not marketing campaigns. Here's the first variation. The actual data which it was trained on, but in this case for the data set, is a yes, and it scored it as a no, but it did that fairly quickly. That's obviously because the model isn't 100% accuracy. We got a 0.91, but that gives you an idea.
Now, building the model accurately is one thing, but putting it into production and allowing for things like model drift and data drift is another. So how do we operationalize our model once it's built, whichever means we use to build it? Let's take a look at that next.
So here you want to talk about MLops, right? So MLops follows DevOps, which has become very popular, and there are some equivalents. You look at code reproducibility, we talk about model reproducibility, model validation, retraining for model drift, for example. And I would say the goals that I've put down here of MLops would be faster experimentation and development, because you have that process there built in. Faster deployment of models into production, so the deployment needs to be easy. And quality assurance. And you want all the info about your model being logged, and that is there. I'll show that to you. So I'll just spend a minute, because we're almost out of time on this, but this is a subject on its own. MLops with Azure machine learning follows the DevOps process, and you've got your shared data sets, environment setup, and I showed all of that to you. It's a common environment, and you train your model, and you validate, equivalent to testing on the dev side. And then when you deploy, and you could deploy back into the cloud, or you could even bring down and deploy onto the edge, keep in mind, you want an easy process to redeploy version, but you want stats, model performance analysis. Now all of that is being collected. So for example here, remember, here's a model that I deployed. Now I created this using AutoML, the simplest creation process, but in the end I have a model, just like any other. If I go to artifacts, you will see model.pkl. That's the actual file with all the data that I can download. I've deployed an endpoint as well, and I can also create explanations and fairness. I'll come back to that, but this is the endpoint. So all of that is being collected and maintained to facilitate this process, right? And then, so you've got that AML extension for Azure DevOps. So this, all of this could feed this data into Azure DevOps as part of that process, and you have audit trail and management. So I'll put a link. It's a subject on its own, but I'll put a link to this page here, which is the MLOps page in my deck, so that you guys can access that. So in terms of responsible AI, there are two things. One is explainability, because if you cannot explain how the model got to its predictions, there are massive implications going forward. And the other is fairness. So even if you can explain how, is there some kind of bias in the model? We looked at examples running a marketing campaign, but things like granting a home loan, you don't want any element of bias there, and it may be that the data is biased, even unintentionally, right? So there are two very important open source platforms, Interpret ML for explainability and FairLearn, and just show this to you, that we incorporating into Azure ML, which is good. So do some reading up on FairLearn, and there are some good examples of model interpretability. You saw I can create an explanation even in the AutoML, but there's even Python code now to bring these libraries in and then run Azure ML.interpret. There we go, that's a package, and try to get that for if you're running in the notebook environment, right? All of this is once again part of simplification, bringing that into this common platform, and that's quite useful. So lastly, before I wrap up, the platform ecosystem is also very important, right? Everything underlying is hidden and exposed. Now you'll notice in everything I did, all the demos, I don't care about what CPU I'm running, what flavor of OS, Linux or Windows. That's all running under the hood, and if there are changes to be made, that will be transparent. You as the user will still see this interface or these sets of interfaces, right? That was another goal, that separation and abstraction. So that's quite important. Just resizing a node there. So those cover what we would need to do to simplify machine learning and what we've achieved thus far.
So that was a quick run through of simplifying ML for the enterprise. I do hope you enjoyed that. We had a lot to cover in just 30 minutes. And as I said, perhaps next year I will see you in person. Until then, enjoy the rest of the show.